concerned with the physical preliminaries of life, with the elaboration of those energy systems which may serve as the physical vehicles for the living energies of elementary material organisms. In a way, the physical controllers are related to the pre-living manifestations of material energy as the adjutant mind spirits are concerned with the pre-spiritual functions of material mind. These intelligent creatures of power control and energy direction must adjust their technique on each sphere in accordance with the physical constitution and architecture of that planet. They unfailingly utilize the calculations and deductions of their respective staffs of physicists and other technical advisors regarding the local influence of highly heated suns and other types of supercharged stars. Even the enormous cold and dark giants of space and the swarming clouds of stardust must be reckoned with. All of these material things are concerned in the practical problems of energy manipulation. The power-energy supervision of the evolutionary inhabited worlds is the responsibility of the master physical controllers, but these beings are not responsible for all energy misbehavior on Urantia. There are a number of reasons for such disturbances, some of which are beyond the domain and control of the physical custodians. Urantia is in the lines of tremendous energies, a small planet in the circuit of enormous masses, and the local controllers sometimes employ enormous numbers of their order in an effort to equalize these lines of energy. They do fairly well with regard to the physical circuits of Satania, but have trouble insulating against the powerful Norlatia deck currents. 3. Our starry associates. There are upward of 2,000 brilliant suns pouring forth light and energy in Satania, and your own sun is an average blazing orb. Of the 30 suns nearest yours, only 3 are brighter. The universe power directors initiate the specialized currents of energy which play between the individual stars and their respective systems. These solar furnaces, together with the dark giants of space, serve the power centers and physical controllers as way stations for the effective concentrating and directionizing of the energy circuits of the material creations. The suns of Nebadon are not unlike those of other universes. The material composition of all suns, dark islands, planets and satellites, even meteors, is quite identical. These suns have an average diameter of about 1 million miles, that of your own solar orb being slightly less. The largest star in the universe, the stellar cloud Antares, is 450 times the diameter of your sun and is 60 million times its volume. But there is abundant space to accommodate all of these enormous suns. They have just as much comparative elbow room in space as 12 oranges would have if they were circulating about throughout the interior of Urantia, and were the planet a hollow globe. When suns that are too large are thrown off a nebular mother wheel, they soon break up or form double stars. All suns are originally truly gaseous, though they may later transiently exist in a semi-liquid state. When your own sun attained this quasi-liquid state of supergas pressure, it was not sufficiently large to split equatorially, this being one type of double star formation. When less than 1/10 the size of your sun, these fiery spheres rapidly contract, condense, and cool. When upwards of 30 times its size, rather 30 times the gross content of actual material, suns readily split into 2 separate bodies, either becoming the centers of new systems, or else remaining in each other's gravity grasp and revolving about a common center as one type of double star. The most recent of the major cosmic eruptions in Orvonton was the extraordinary double star explosion, the light of which reached Urantia in AD 1572. This conflagration was so intense that the explosion was clearly visible in broad daylight. Not all stars are solid, but many of the older ones are. Some of the reddish, faintly glimmering stars have acquired a density at the center of their enormous masses, which would be expressed by saying that 1 cubic inch of such a star, if on Urantia, would weigh 6,000 pounds. The enormous pressure, accompanied by loss of heat and circulating energy, has resulted in bringing the orbits of the basic material units closer and closer together until they now closely approach the status of electronic condensation. This process of cooling and contraction may continue to the limiting and critical explosion point of ultimatonic condensation. Most of the giant suns are relatively young. Most of the dwarf stars are old, but not all. The collisional dwarfs may be very young and may glow with an intense white light, never having known an initial red stage of youthful shining. Both very young and very old suns usually shine with a reddish glow. The yellow tinge indicates moderate youth or approaching old age, but the brilliant white light signifies robust and extended adult life. While all adolescent suns do not pass through a pulsating stage, at least not visibly, when looking out into space you may observe many of these younger stars whose gigantic respiratory heaves require from 2 to 7 days to complete a cycle. Your own sun still carries a diminishing legacy of the mighty upswellings of its younger days, but the period has lengthened from the former 3 1/2 day pulsations to the present 11 1/2 year sunspot cycles. Stellar variables have numerous origins. In some double stars, the tides caused by rapidly changing distances as the two bodies swing around their orbits also occasion periodic fluctuations of light. These gravity variations produce regular and recurrent flares, just as the capture of meteors by the accretion of energy material at the surface would result in a comparatively sudden flash of light which would speedily recede to normal brightness for that sun. Sometimes a sun will capture a stream of meteors in a line of lessened gravity opposition, and occasionally collisions cause stellar flare-ups, but the majority of such phenomena are wholly due to internal fluctuations. In one group of variable stars, the period of light fluctuation is directly dependent on luminosity, and knowledge of this fact enables astronomers to utilize such suns as universe lighthouses, or accurate measuring points for the further exploration of distant star clusters. By this technique, it is possible to measure stellar distances most precisely up to more than 1 million light-years. Better methods of space measurement and improved telescopic technique will sometime more fully disclose the 10 grand divisions of the superuniverse of Warbanton. You will at least recognize 8 of these immense sectors as enormous and fairly symmetrical star clusters. 4. Sun density. The mass of your sun is slightly greater than the estimate of your physicists, who have reckoned it as about 2 octillion, 2 times 10 to the 27th, tons. It now exists about halfway between the most dense and the most diffuse stars, having about 1.5 times the density of water. But your sun is neither a liquid nor a solid. It is gaseous, and this is true notwithstanding the difficulty of explaining how gaseous matter could attain this and even much greater densities. Gaseous, liquid, and solid states are matters of atomic molecular relationships, but density is a relationship of space and mass. Density varies directly with the quantity of mass in space and inversely with the amount of space in mass. The space between the central cores of matter and the particles which whirl around these centers, as well as the space within such material particles. Cooling stars can be physically gaseous and tremendously dense at the same time. You are not familiar with the solar supergases, but these and other unusual forms of matter explain how even non-solid suns can attain a density equal to iron, about the same as Urantia, and yet be in a highly heated gaseous state and continue to function as suns. The atoms in these dense supergases are exceptionally small. They contain few electrons. Such suns also have largely lost their free ultimatonic stores of energy. One of your nearby suns, which started life with about the same mass as yours, has now contracted almost to the size of Urantia, having become 40,000 times as dense as your sun. The weight of this hot, cold, gaseous solid is about 1 ton per cubic inch, And still this sun shines with a faint reddish glow, the senile glimmer of a dying monarch of light.